974 systems of equations. This is substitution day 2. We talked about substitution, and basically what it is an algebraic method to solve systems of equations to find that point of intersection, or how many solutions there would be given two equations. And here's our 4 steps that we covered yesterday. Yesterday we did not need to take step 1. Okay, we didn't need to solve for one variable, meaning get a variable alone, kind of like literal equations. We will need to take this step today, and then we'll follow along with 2, 3, and 4. So here's example 1. You have y equals 7 and negative 8x plus 3y equals 21. Note that here in step 1, it is actually already solved for. So we already know that y equals 7. It's telling us that y is 7. So solution here that we have is y value is 7. We already know that. So basically what we need to do is figure out x. Well, we know y is equivalent to 7, so we're going to put 7 in for y into the second equation. Here's that second equation, negative 8x plus 3 in for y. Remember, y equals 7, so I'm going to put in 7 for y equals 21. Negative 8x plus 21 equals 21. Solve for x. Subtract 21 from both sides. And we have negative 8x equals 0. Get x alone. We're going to divide by negative 8. And when we divide by negative 8 on both sides, we find out x equals 0. 0 divided by negative 8 is 0. So we'll put that in our solution, and we're done there. Our solution, or our point of intersection, where those two lines will intercept, is 0, 7. As we check out the second problem here, note that neither equation is solved for. So you need to solve for a variable. Rule of thumb here, the easiest way to save you some steps in the end is solve for a variable that has a coefficient of 1. So the number out in front. So if we look at that first equation here, x has a coefficient of 1. So we want to go ahead and get x alone. All the other variables have coefficients of negative 5, negative 2, and negative 4. So we're going to solve for x in equation number 1. This is step 1. So we have x minus 5y equals 1. Get x alone, I would add 5y to both sides. I would come up with x equals, this is a positive 5y, and that was a positive 1. Now that you have an equation solved for a variable, you can go ahead and plug in. So we know x is equal to 5y plus 1. They're saying the same thing. So we're going to put 5y plus 1 in for x into equation 2. So we have negative 2 parenthesis 5y plus 1, no longer using x, minus, carry out the rest of the equation, 4y equals negative 16. What you've done is you've eliminated a variable, so now in this problem we're solving for y. Distribute, we have negative 10y. Distribute, we have negative 2 minus 4y equals negative 16. Next, I'm going to go ahead and combine like terms on the left side. That is negative 10y and negative 4y. That is negative 14y. I'm going to drop down negative 2 equals negative 16. Get y alone, add 2 to both sides, and we wind up with negative 14y equals negative 14. Get y alone, divide by negative 14 to both sides, and we find out that y equals, well, negative 14 divided by negative 14 is 1. So there is our y value. So our solution that we have, we know y is 1. So what you need to do is take that y value and plug it into one of your original equations, that being this first one or the second one. You could actually even plug it into this equation down here, x equals 5y minus 1, because this is really the same equation as that top equation. So really it doesn't matter what one you plugged it in for. I'm going to go ahead and plug it into this equation that I have here to figure out x, because I have x by itself. So I have x equals 5y plus 1. Substitute in 1 for y. I have x equals 5 times 1 plus 1. And we get x equals 5 plus 1. We find out x equals 6. So our solution is 6, 1. Example 3, first step, get a variable alone. I'm going to get x alone because x has that coefficient of 1. So I would add 5y to both sides. After I do that, I have x equals 5y plus 5. I can now substitute into equation 2. I have this substituted in for x, so I'm getting rid of my x value. Distribute your 2. We have 10y. Distribute your 2 again. We get a positive 10 minus 10y equals negative 6. Combine your like terms. Here's my like terms. A positive 10y, a negative 10y would cancel. So we drop down 10 equals negative 6. This here is not a true solution. If it's not true, this answer, and we've covered this before, where we have a number equal to a number and it's not true, it is no solution, which is telling you that these lines would be parallel. That means, remember, the solution is they do not intersect. So this is why you would have no solution. There would be no intersection. I wouldn't have x equals a number like in example 2, we came up with y equals a number and x equals a number. That's our point of intersection. That is our solution with systems of equations. So no solution there in example 3. Check out our 2 equations here in example 4. Definitely going to solve for x for equation 2. That's the one that has a coefficient of 1. That would be the easiest to solve for. So I'm going to go ahead and add 6y to both sides. To get rid of it, we have x equals negative 6y plus 6y would cancel. We have a positive 6y and a negative 20. So there is the new equation. We're going to go ahead and substitute this x up here in equation number 1. So we have 2 instead of x. We know x is equivalent to 6y minus 20. And then carry out the rest of that equation. First step here is to distribute that 2. We have 12y. We have negative 40. We have negative 12y equals negative 40. Combine your like terms on the left side. We have a positive 12y, a negative 12y would cancel. So we'll drop down the negative 40 equals negative 40. Okay, again, this portion, when you have something equal to one another and it checks out, it is a true statement. That is telling you that they have solution, and it is an infinite number of solutions. Remember what infinite means. Infinite means these two are basically both the same line. If you were to put them in slope-intercept form, they would be the same line on top of one another. So it has an infinite number of solutions. This will conclude 974 Systems of Equations, Substitution, Day 2.